For a lot of these issue where we cannot directly interpret correlation between two variables to be a causal one, it could be due to many reasons, and this is what we usually call the endogeneity issue. One reason is that there might be omitted variable. Okay, so what is that? So suppose we want to know the causal relationship between x and y, and so the direction, there's an arrow there, right? So and so we know to what extent the change in x caused the change in y, or something kind of. Let's think about x as some sort of interventions. The problem is if we just look at the correlations, again, if we go back to our example of education schooling, there might be some omitted variable, right? So maybe to some extent, education make people more skillful, more human capital, more knowledgeable, and that increase earning. But maybe those people who got more educations, they might be more persistent, they work harder, and so on. And so even if they don't go to uni or they don't got a lot of years of schooling, they would have high income to begin with, or higher income to begin with. So maybe the gap between people who have more schooling and people who have less schooling, in part is because this kind of omitted variable. We don't observe how hard people work, we don't observe how creative they are, how persistent they are, and so that or they're intelligent and so on. And now we have these things, omitted variable. And so we don't know whether one more year of schooling increase people's earning by 12% or 10% or 8%. We want to know the causal impact. If that kind of person, a same group of people got one more year of schooling, how many, what percentage of earning on average they would got? So that's causal impact. And one way to deal with it was, well, and this is some people early on tried to do. In some country, initially people think, okay, in this omitted variable, maybe intelligence is a big factor. Usually don't observe that, but in some country, okay, some people, they apply to the R-force in US and some other country, and as a requirement, they need to do an IQ test. And so in that subsample, they can control IQ, well, whatever it was, in terms of affecting their earning. And then they sort of, okay, it turned out that they control for it, and the correlation is still really strong. And so, so maybe, you sort of, in a way, this is the idea of conditional unconfoundedness. So basically, you say, okay, U is small enough once we put in a lot of data there. So you control for it in a way. But the thing is, well, people still, well, yeah, maybe IQ, you can control for it and still don't see the coefficient change a lot. But maybe there are other things. Maybe you can't measure how persistent, how hardworking people are. So the potential drawback is that while you might still have a lot of this confounding variable that you haven't captured yet. So one way to deal with it is to what we call using an instrumental variable, IV. The idea is that if you have some sort of variable, that only affect X, the variable that you really want to get its causal impact, but not anything else. And you know, IV itself is uncorrelated with other unobservable, and its impact on Y is only through X. Okay, so go back to our previous example. Let's X is year of schooling, Y is earning. U is maybe intelligent, persistent, and so on. Okay, if we can do experiment, we randomize people's year of schooling X, and that's it. But we can't. So can we think of some instrumental variable that affect people's year of schooling, okay, but not earning directly, right? So for example, in some places, some charity organization, some university, we say, okay, we're going to give out scholarship, but we have this fixed number of scholarship. So for all those who are eligible, we can't give it to all. So for those who are eligible, we just whoever won the lottery, I got it. So in those cases, you can if people got data and say, okay, whether people got scholarship or not, it probably affect people's decision to got year schooling if financial constraint is a factor, or maybe sometimes which school they go to. And that, because it's through a lottery, is covered, well, it's random. And therefore, it's uncorrelated with this unobservable. It's not going to affect people's earning because the lottery itself is not going to affect people's earning, except through affecting people's decision to take enroll in a university or not. Okay, and that changed years of schooling and so on. So in that case, the instrument variable is going to be helpful for us to get the relationship from year of schooling and earning. Okay, it doesn't have to be earning. There's other benefits of education as well. And the vast literature in that study is just bring down, okay, the causal relationship between a year of schooling and earning, it varies from country to country, but tend to be quite large, and on the magnitude to 8 to 15%. And that's instrument variable. Here's another example where people use this innovative idea. Again, it comes from Joshua English, many years before he got the Nobel Prize, and Bill Evans. So people who study labor market, they interested in labor supply, right? How people decide how many hours, whether or not they work in the labor markets. And one thing that we know, or so the hypothesis may sort of affect people's labor supply, particular women, because historically the labor force participation of women has been lower than men. So they want to know, okay, whether children and their parents have a causal impact, the number of children, whether they have a causal impact on parents' labor supply. The problem though is endogeneity, right? There's a lot of factors affecting people's decision to have children and affecting people's decision to have to work or not. Okay, child care, whether family have other incomes, all kinds of reasons. So a correlation, right, it does not mean causality, and maybe or maybe sometimes the labor, the job is so demanding and they can't have children and so on. Right? So they think really hard and come up with a really innovative instrumental variable. And that is the gender composition of first two children. Okay, so this is done in the context US. We know that the gender of children is going to be random. Right, the biological science tells us that. And in US, right, not everyone, but in the sample there, right, there's a kind of a preference, a small preference for parents to have a mixed gender of their children. So to cover to that shape, so not all parents, but a large enough share of parents would say, okay, we have one boy and we have one girl. Here the order doesn't matter that much. And they say, okay, that's it, no more child. We got one boy and one girl. For some parents, they have the first two children, they're both boys. Okay. And so they might, okay, it would be nice if we have a daughter. And so okay, perhaps have one more child. And similarly, right, if the first two children are both girl, they might say, well, maybe try one more and see whether we got a boy. Right. So we know the gender of children is going to be random. And so the gender compositions of the first children is going to be random, whether they have the same genders or not. Okay, same gender or not. And so that kind of randomness, that kind of experiment done by the nature, induce whether a subset of parents, whether they have two children or three. And that's precisely using that instrument variable, which is for those have two or more children, for those parents with two or more children, whether the genders of the first two children are the same or not. Okay, and using that kind of randomness, okay, they got exogenous variations in number of children, 2 or 3, and figure out, okay, indeed, the number of children impact people's labor supply decision, to what extent they work full-time, part-time, what kind of job they take, and so on. And so in this case, yeah, so they sort of use observational data, how many children and the gender composition people have, using natural experiment and tease out causal relationship. Okay. So